So good morning. So myself and my colleague Farid Kendul, who's sitting up the back, have been conducting research on drones for the last 10 years at CSIRO. We're both research scientists in CSIRO. We have PhDs in drone autonomy, and we've developed some pretty amazing technology in CSIRO over the last 10 years, and we're really passionate about commercializing this technology. We're also passionate about enabling the widespread use of drones by making them safe and easy to use. At the same time, in our robotics group, another group of researchers have developed some amazing 3D mapping technology, which is commercialized in the form of Zebedee, which some of you guys might have been familiar with. So for us, it was a sort of a natural combination to bring these two technologies together to create what is Hovermap. So I think there's no doubt we're all aware of the exploding drone market. Drones are a hot topic, and they have massive potential to change the way we live and do great benefits in our everyday lives. It's already projected to be a $20 billion market by the year 2020. However, there are a couple of key limitations with existing drones that you can buy off the shelf, which is preventing them from reaching this full potential. First of all, they all lack the onboard sensing and intelligence to avoid collisions. Secondly, they require GPS for navigation, so there's just many places they can't be used, such as indoors, underground, in storm tunnels, or even close to tall structures such as buildings that interfere with GPS. And lastly, they all need at least one expert on the ground to control a single drone in the sky. So it just doesn't scale up to large applications like delivering millions of packages around the world. It's not possible with today's technology. So Hovermap solves these problems with a unique combination of hardware and software. I just brought along one of our prototypes to show you today to give you an idea of the size and scale. But this combination, first of all, generates amazing 3D maps of the environment as it flies around, whether it's underneath a bridge, inside the Sydney Opera House, power line inspections, the Amazon jungle, or a construction site. The mapping results are really incredible, and there's nothing else in the market that can produce maps of this detail without GPS from the air. In addition to using the laser for doing 3D mapping, we're also using it in real time to solve a couple of problems. First of all, we generate a virtual invisible shield around the UAV to avoid collisions. Secondly, we use the SLAM in real time to avoid the need for GPS, so drones can fly anywhere. And thirdly, with the onboard autonomy, it means a single untrained operator can supervise a whole swarm of drones, which really allows them to scale up. So with these key capabilities, we can address a whole range of different market segments, but the area we've had the most pull from is asset inspection. So asset owners have realized that by allowing drones to fly safely up close to or inside their assets, they can reduce the time, cost, and risk of inspecting them, and also collect type of data that they've never been possible to collect before. So for example, cell phone towers, instead of sending a crew to go and climb a cell phone tower, which costs a couple of $1,000s, it takes half a day and obviously involves working at heights. With a single click of a Hovermap-enabled drone, we can get the job done in 10 minutes for a fraction of the cost, and nobody has to climb a tower. So in addition to generating these amazing 3D maps, we can also add value by extracting useful information from the maps. At the end of the day, this is really what the clients want. So, for example, we can determine where their antennas are pointing on a cell phone tower, or even tell if anything's changed over time on the tower. So our revenue streams are threefold. First of all, we'll sell hardware. Secondly, there's software as a service on top of that to process the data to generate 3D maps and extract useful information. And thirdly, we'd license our software and algorithms to drone manufacturers, so that the non-GPS flight, collision avoidance, and autonomy becomes a standard part of the millions of drones sold around the world in the future. So this is really the key to our growth, is this transition from a hardware to a software company. And this has really been enabled by the reduced cost, weight, and size of LiDAR sensors in the coming years. And this is driven by the autonomous car market. So in a couple of years, almost every commercial and consumer drone will have the sensors on board for doing collision avoidance, and they'll be relying on the algorithms which we are developing. So to date, we've built 2 working prototypes. We've tested them extensively in different market segments, doing demos and trials. And this has been while incubating within CSIRO with incredible support from CSIRO. And we're getting to the point now where we are ready to commercialize this and to spin out. So we are looking for the external investment and setting up an early adopter prototype program so we can have these units tested in the real world. So to make this possible, obviously, we need external investment, but we're also looking for to grow our team, especially with business experience, any vital connections to major companies such as Intel, for early access to hardware, and in general, mentors and advisors. So looking forward to having a chat with all of you later. Thank you.